What you see before you is the global map of submarine communication cables, with a total length exceeding 1.3 million kilometers, capable of circling the Earth 32 times. It carries 99% of global data traffic and allows you to receive information from any corner of the world. So how exactly does it transmit signals? We know the speed of light, the fastest known speed, is about 300,000 kilometers per second, letting it circle Earth 7 times in 1 second. So, using light to send information is very efficient. But since light travels straight in a vacuum, if the optical fiber bends, the light might escape into the air. How then can light propagate through a bent optical fiber? According to the law of refraction, when light enters different media, its direction of propagation changes, resulting in refraction. For example, when a pencil is placed in water, it appears as if it is broken. If we were to turn on a laser pointer underwater, we would observe that the light beam experiences slight refraction as it travels into the air. If the angle is adjusted to hit the critical angle, the light won't pass through the water surface but will fully reflect back underwater. This is called total internal reflection. This means that as the angle of the incoming light changes, the angle of the refracted light changes too. When the angle of incidence goes beyond a certain point, the refracted light will suddenly bounce back into the original material. By using this trait, light can be controlled within the optical fiber, allowing it to travel far. However, since the core is a very fragile transparent filament made of glass or plastic, it needs a protective layer. If this layer isn't transparent, total internal reflection won't happen. In response to this, engineers decided to encase the core with a layer of glass as cladding and add some substances inside to achieve this. Lower the refractive index of the cladding and finally use materials like aramid fiber or steel to make a protective sheath to prevent physical and environmental damage to the core. When a light beam enters the core, it is reflected each time it reaches the cladding edge, allowing it to be transmitted over long distances along the fiber optic cable. So how does fiber optics transmit information? First, any information can be converted into binary, turning it into a sequence of zeros and ones. If you send a greeting to someone across the Earth, the text converts into binary code of zeros and ones, then transmits as electromagnetic waves to a nearby signal tower. The signal tower will then convert it into a series of light signals, where brighter light represents the number 1 and dimmer light represents the number 0. By adjusting the brightness of the light, this information can be conveyed. To ensure that this light can be transmitted smoothly along the fiber optic cable to the other side of the Earth, 5 billion kilometers of fiber optic cables have been laid under the sea and underground worldwide. Since the signal in the fiber optic cable will significantly weaken after exceeding 100 kilometers, many repeaters are used along the way to amplify the light signal. Additionally, to power the repeaters, a layer of copper tubing is added to the undersea cables, which is why they appear so thick. Currently, the signal tower sends light pulses into the fiber optic cable, traveling through forests, over hills, and into the complex undersea cable network, finally reaching the signal station on the other side of the Earth. It's then sent again as electromagnetic waves to the phone, converting back into the text. This way, the other party can see the message. The entire process takes less than a second. It is precisely the advent of fiber optic cables that has completely transformed our current communication methods. It must be said that human wisdom is truly boundless.